All right, let's dive headfirst into one of the most mind-bending ideas in all of science. It's a concept that completely messes with our most fundamental experience of reality. I'm talking about the present moment, the now.
I mean, think about it. Right now, as you're listening to this, it feels like this exact moment is happening for everyone, everywhere. On Mars, in a galaxy a billion light years away, it all seems to be happening at the same shared instant. It's just obvious, isn't it?
Well, get ready for this. It's not. It turns out that our deeply held belief in a universal now is nothing more than a stubborn illusion. And back in 1905, Albert Einstein is the one who proved it. So let's unpack exactly how he pulled it off.
So where did we even get this idea of a shared present moment? Well, it comes straight out of the world of Sir Isaac Newton. For hundreds of years, his ideas were the absolute bedrock of physics.
You see, Newton imagined time as this great cosmic river just flowing along at the exact same rate for everybody and everything in the universe. In his clockwork universe, a single master clock was ticking for all of existence. It felt so right, so intuitive, but it was about to be completely shattered by two surprisingly simple rules.
Now, to get what Einstein figured out, you don't need a PhD in physics. You just have to accept two basic principles, two unbreakable rules of the game that the universe has to play by.
Okay, so rule number one is actually a pretty old idea. The laws of physics, things like gravity and motion, work the same for everybody, as long as they're moving at a constant speed. But rule number two is the real troublemaker. It says the speed of light is always the same for every single person who measures it, no matter how fast they're moving.
And that second rule creates a massive problem for our common sense, right? If you're on a train and you throw a baseball, someone on the ground sees the ball moving at the speed of the train plus the speed you threw it. But if you shine a flashlight forward, both you on the train and the person on the ground measure the light moving at the exact same speed. How can that be? To solve this crazy paradox, Einstein realized something huge, something monumental, had to be thrown out: Newton's idea of a single absolute time. And to show us just how this works, Einstein came up with this brilliant thought experiment. So welcome to the scene of the crime, the very place where our comfortable idea of now gets completely dismantled.
So, picture this. We've got our first observer, Mike. He's just standing still on a railway embankment. And then we have Nina. She's sitting in the dead center of a very long train that's speeding right past him.
Now for the big event. At the precise instant that Nina, on the train, is directly across from Mike on the embankment, two bolts of lightning hit the train. One strikes the very front, and the other strikes the very rear. Now, here's the crucial part. From where Mike is standing, these two lightning strikes happen at the exact same time. They are perfectly simultaneous.
Okay, so let's see this from Mike's point of view. He's standing perfectly in the middle of where the two strikes hit. The light from the front flash and the light from the rear flash travel towards him, and since the speed of light is constant and the distances are equal, that light reaches his eyes at the exact same moment.
So, his logic is totally sound. He saw the light from two events which were the same distance away from him arrive at the same time. His conclusion? The lightning strikes were simultaneous. Makes perfect sense, right?
But what about Nina? What does she see? From her perspective on that moving train, things get weird. And remember, that unbreakable rule, the speed of light is constant for everyone, applies to her too. This is the absolute key to the whole thing. In the tiny fraction of a second it takes for the light to travel from the ends of the train to the middle, Nina herself has moved forward. So she's actually racing towards the light coming from the front strike, but she's moving away from the light coming from the rear strike. Because the light from the front has a shorter distance to cover to reach her, and the light from the rear has a longer distance, the result is completely unavoidable. Nina sees the flash from the front of the train first. So now we've got a problem. We have two observers with two totally different observations. Mike saw the flashes happen at the same time. Nina saw the front flash happen first. So whose clock is right? Who's telling the truth? Well, let's think like Nina for a second. Her logic is just as flawless as Mike's. She knows for a fact she's in the middle of her train, and she knows that unbreakable rule. The speed of light is constant. So if the light from the front reached her first, there's only one possible conclusion she can make. The lightning strike at the front of the train must have happened before the strike at the rear. And here it is, the heart of the paradox. Mike correctly concludes the events were simultaneous. Nina correctly concludes the front event happened first. They are both 100% right according to the laws of physics. They just fundamentally disagree on the order of events. They can't both be right, or can they?
This is the bombshell. This is what Einstein called the relativity of simultaneity. What it means is that whether two things happen at the same time completely depends on how you're moving. There is no single universal now. Mike's now and Nina's now are just two different equally valid slices of reality.
And let me be really clear about this. This is not some kind of trick of the light or an optical illusion. It's a real physical disagreement about the actual timing of events in the universe. The universe simply doesn't have a master clock that we can all agree on.
Now, this idea might sound a little abstract, maybe a little out there, but its consequences are absolutely profound. It completely reshapes how we have to think about the entire cosmos.
See, once you get rid of a universal now, other weird dominoes start to fall. If two people can't even agree on when events start and stop, well then they also can't agree on how long they take. And that is the very root of another famous effect called time dilation. The wild fact that moving clocks actually tick slower.
And believe me, this isn't just some wacky theory. The GPS in your phone, the one you use every day, relies on it completely. The satellites orbiting Earth are moving so incredibly fast that their clocks literally run slower than ours down here. If the engineers didn't correct for this relativistic effect, your GPS would be off by about 10 kilometers every single day. It would be totally useless.
So what Einstein's little thought experiment really does is force us to ask some pretty deep questions about reality itself. It shows that the solid, stable, shared present that we all feel is just our local illusion. And that leaves us with a fascinating final thought to chew on.